Modernage MCQs Physics class first year, unit number 8, weights, part number 3. Which one remains constant when a wave enters from one medium into another? Option A, frequency. Option B, wavelength. Option C, phase. Option D, velocity. The key is frequency. Therefore, the option A is correct. Reason: the velocity of wave v is equal to square root e divided by rho depends upon the elasticity A, E and density rho. Different media have different values of E and rho, therefore velocity changes. In equation, v is equal to f lambda. Lambda is the wavelength. The lambda also changes with change in velocity because it is defined as delta x divided by delta t equal to length per unit time. Hence, the frequency of the wave remains constant. In transverse waves, a crust is separated from a consecutive crust by option A, lambda by 2, option B, lambda by 4, option C, lambda, option D, 2 lambda. The key is lambda. Therefore, the correct option is C. Reason: the distance between two consecutive crusts is called the wavelength of the wave and it is usually denoted by lambda. Hence, a crust is separated from a consecutive crust by lambda. In a transverse wave, the distance between a crust and trough is equal to option A, lambda by 2, option B, lambda by 4, option C, lambda, option D, 2 lambda. The key is lambda by 2. Therefore, the correct option is A. Reason: the distance between two consecutive crusts is called wavelength of the wave and it is usually denoted by lambda. There is always a trough between two consecutive crusts of a transverse wave. Therefore, the distance between a crust and a trough is equal to half of the wavelength, lambda by 2. Hence, the distance between a crust and trough is lambda by 2. If the velocity of sound in steel is Vs and in air is Va, then option A, Vs is equal to Va, option B, Vs is less than Va, option C, Vs is greater than Va, option D, Vs is equal to Va square. The key is Vs is greater than Va. Therefore, the correct option is C. Therefore, the velocity of sound V is equal to square root E divided by rho. The ratio E to rho is equal to the ratio elasticity to density for steel is very much greater than the ratio E to rho elasticity to density for air. Hence, the velocity of sound in steel is greater than the velocity of sound in air. The velocity of sound increases at the rate of 0.61 meter per second per degree centigrade. The increase in velocity for 40 degrees centigrade rise in temperature of medium will be option A, 40 meter per second, option B, 24 meter per second, option C, 16 meters per second, option D, 6.1 meters per second. The key is 24 meters per second. Therefore, the correct option is B. Reason: in the formula, V is equal to V naught plus 0.61 T. The term 0.61 T is the increase in velocity for T degrees centigrade rise in temperature of the medium. Therefore, for 40 degree centigrade rise in temperature, the increase in velocity is 0.61 into 40, which is 0.24.4 meter per second. Rounding the figure is equal to 24 meter per second. Hence, the increase in the velocity is 24 meter per second. If an ambulance enters in a region of high temperature with sounding hooter, then option A, speed of sound increases, option B, frequency of sound increases, option C, speed of sound decreases, option D, frequency of sound decreases. Key is speed of sound increases. Therefore, correct option is A, reason. In the formula, V is equal to V naught plus 0.61 T. The term 0.61 T is the increase in velocity for T degree centigrade rise in temperature of the medium. Therefore, when an ambulance enters in a region of high temperature with sounding hooter, then speed of sound increases. Hence, the speed of sound increases. Two light transverse pulses are approaching each other along a fixed ends string will form. Option A, compression waves. Option B, transverse waves. Option C, standing waves. Option D, polarized waves. The key is standing waves. Therefore, the correct option is C. Reason. When two transverse pulses of same amplitude, frequency and speed superposed, the fixed end string vibrates in loops as the energy is confined in the region of string. Therefore, the waves are called standing or stationary waves. Hence, two like pulses approaching each other form standing waves, which cannot be observed in the sound waves. Option A, reflection. Option B, refraction. Option C, diffraction. Option D, polarization. The key is polarization. Therefore, the correct option is D, reason. The polarization is unidirectional vibration of particles of medium perpendicular to the direction of propagation of waves. The sound waves are compressional, or we can say that longitudinal waves. The vibration of particles of the medium is parallel to the direction of propagation of waves. Hence, the sound waves cannot be polarized. When a wave enters from a denser medium to rare, which one remains constant? Option A, phase. Option B, speed. Option C, frequency. Option D, wavelength. The key is frequency. Therefore, the correct option is C. Reason. In relation V is equal to F lambda, the speed of a wave depends on the medium. Medium depends upon density, which is mass per unit length, m divided by L. When a wave enters from denser to rare medium, the change in speed delta V will change the wavelength delta lambda. The frequency f is constant of proportionality because V is proportional to lambda. Hence, the frequency of wave remains constant. In a region, some particles are at rest and some are oscillating with maximum amplitude. The region contains option A, transverse waves, option B, longitudinal waves, option C, polarized waves, option D, stationary waves. The key is stationary waves. Therefore, the correct option is D. Reason. In stationary waves, the particles at nodes are at rest while the particles at antinodes are oscillating with maximum amplitude. As some particles are at rest and some are oscillating with maximum amplitude in the region, therefore, the region contains stationary waves. It is the property of stationary waves. Hence, The region contains stationary waves.